Welcome to FOBtv, the future of business. I'm your host, Kevin Benedict. I'm a futurist and lecturer here at TCS, and I want to thank everyone for joining the program today. I'm really excited to introduce our guest today. He's Zvi Feuer. He's with Siemens. He's the Senior Vice President with Digital Manufacturing Software and CEO of Siemens Digital Industries Software out of Israel. Thanks for joining us, Zvi.
Yeah, thank you for hosting me. A pleasure.
Absolutely. Where are you calling in from today?
I'm actually on a ski vacation in Austria.
Yeah. Our gratitude is even greater that you would join us while on vacation.
Zvi said it's urgent and important, and I said, okay, I will join. We want to support each other in Siemens and make sure that we are successful together.
That's terrific. So now tell us about your personal use of generative AI. How often are you using it on a daily basis or weekly basis?
I personally use it since it was announced by OpenAI. I use it almost every day. I use all kinds of different tools, but what's more important, I'm trying to push it into our daily life in DI software, digital manufacturing, in various ways. First of all, in using it on a regular basis as an assistant tool for software development, use it in different capacities to develop AI tools, AI agents that will be added or are already added into our products to support our customers to do the job in a better way. We recently had a hackathon where all the PLM segments under Joe Bowman in our company have participated. We had I think close to 500 groups who submitted ideas. We gave them 2 days to run this hackathon. It's called an agent hackathon. They came up with some fantastic ideas, and now we have to sort them out and figure out who are the leading teams, and what are we going to do with these innovations, because there are some very exciting innovations.
Oh, yeah, and I bet it won't be too long before AI completes his own hackathons.
I think it's a bit early. I do believe AI is important. We have started to use AI in our company 30 years back. It wasn't called AI at the point. It was called neural networks.
Right.
And we did a lot of simulation and optimization using neural networks. We then went into machining. We had an inference engine who could identify features on a part and automatically assign the machining operations and tools needed to so-called kill the feature. We even bought a company that was out of Enschede, Holland. The guy who was running the company was a PhD student at the University of Twente. He's still with us. His name is Dr. Tom van der Hoef, and he invented this technology. So AI is not new to us, but the explosion of what AI is capable of doing today is definitely making a big difference. And I think it's going to have an impact on our business for sure. I don't know yet where it's going to be the biggest impact, but we will probably discuss it later in the talk.
Oh, yeah. So in your area of responsibility, Zvi, what are you most excited about today?
I'm a manufacturing guy. I started my career on the shop floor, cleaning the shop floor from chips after they were producing parts on CNC machines. And I grew my knowledge over time, went into assembly, went into composites, went into production of aircraft components, aircraft parts, then joined Technomatics, an Israeli startup that was fully focused on manufacturing, robotics. We have been in the domain of robotics many years, helping companies, especially in the automotive area, to program robots and program production systems. So what I'm excited about is the opportunity to digitalize manufacturing, the opportunity to implement comprehensive digital twins, which are not only digital, but have a replica in the real world and are kept digital, physical, are being connected so that people can do all kinds of what-if analysis on the digital part before they implement it on the real production. So for me, these are the exciting things. What's most exciting as well is our ability to help companies stay competitive. So we see the competition coming from all kinds of areas in the world, and we want to make sure that the companies that we work with are capable of competing against, cheap labor, against all kinds of so-called wizard things, but stay competitive. I believe manufacturing is a big area of human support. So you don't have to be a PhD to be successful in manufacturing. On the other hand, you can gain a decent salary and you can have a good job. So from my point of view, manufacturing, especially in the Western world, is a very important element in making the society more, I would say, reducing gaps in the society and making the society more healthier. Unfortunately, this was not the way of thinking of some of the bigger countries. Look, if you take Germany, they are still at about 20% of the GDP is manufacturing. Mm-hmm. And their economy is still, relatively stable. When you go to France, 20 years back, it was 19%. Today, it's less than 9%. They've taken all the manufacturing out. The administration now, the new administration in America, is doing everything in its power to bring back manufacturing. They just signed a contract with TSMC, the Taiwanese chip company, to build a production facility in America, another one. They don't have enough employees to operate all these facilities. So for me, helping these companies become successful and equalizing the price per unit produced, even though they have much higher labor cost, would be, something I would be, signing off on.
So someday labor costs are going to be less if the dream of developing these fully autonomous manufacturing environments actually happen. Do you agree with that? Do you see that possibility in the next decade?
I do see possibilities where you're going to have more automation and more AI and data-driven manufacturing on the shop floor. I see situations where decisions are going to be made by less people. And in these decisions, we will have a lot of AI to support decision-making. Mm-hmm. So you have a factory running. The factory is connected. All the data is collected. We are collecting enormous amount of data in our factories today. Even in Siemens, we have, 280 factories. We collect a huge amount of data in these factories. But the problem with this data is that we are not necessarily making the best use of this data. Imagine a situation within the next decade where AI agents could be helping us make better decisions. If they can make better decisions, they could help us identify problems before they happen. We can go and fix these problems so we can keep the production running smoothly. We can adjust production. We can fix problems on the shop floor. We can make sure all the logistics is arriving to the right spot at the right time. This is where I see a big change. Are we going to have autonomous factories? Well, I don't see this is happening for all the shifts, but maybe one shift autonomous would be something that I think we could think about. Look, many years back, I've been to Boeing and they were trying to they bought an FMS system. You know, FMS, flexible manufacturing system.
Yes.
It's a bunch of machines connected with a computer, connected with AGVs. They can produce almost anything by themselves. That was the slogan.
Yeah.
This thing didn't work. This was about 30 years back.
Yeah.
Can we do it today? I'm not sure. What we can do today is we can do reconfigurable manufacturing. Mm-hmm. We can have an AGV with a bunch of parts on it going to the next operation. The next operation could be done by 3-4 different machine centers, but some of them are busy. So AI will choose the best one after the one that was chosen at the beginning, and will reroute the AGV with the components to this machine. On the other side of the house, another AI agent will make sure that all the necessary tooling, fixtures, and jigs arrive to this machine, because obviously this machine was not designated for this production system, and so on and so forth. So I see here a lot of opportunities to make a big difference. Automation will be one of the areas. Data will be one of the areas. Logistics on the shop floor. I saw in your write-up, you talk a lot about edge machines. I think edge machines are going to be playing a major role, because, you know, the latency of going to the cloud all the time is not necessarily what we need if we want to take decisions in a very short cycle.
Right.
So edge machines will have an impact here.
Got it. So I have recently watched a demonstration of what they call robo-forming, high-pressure metal forming into different shapes. And they were just showing how the same machines, you know, you may need different metals between them, but in the morning you could be building one set of things, and in the afternoon you're building a different set using the same equipment connected to these different layers. So let me just ask, what are those major kind of technology stacks that are required to do that flexible manufacturing? And you mentioned digital twins and the data and things like that, but what do you think are kind of the major technology stacks necessary for that kind of a manufacturing environment?
Look, specifically, there are specific technologies in manufacturing which are going to be changing dramatically. One of them is this mold and die technology or press technology. I think this is going to change dramatically. I don't think that it's going to be the only way that we're going to produce parts and so on. You remember there was a big hype a couple of years back about 3D printing. Mm-hmm. And if I had $1 for every report that I read about how big this industry is going to be today in 2025, I would be a very rich man. It turned out to be a nice technology. It turned out to be good for certain things. It's not perfect for everything that we want to do. And therefore, I would say there are certain things that we will continuously see in the world of manufacturing. There are going to be some new things. For example, in the domain of robotics, I believe we're going to see slowly humanoids. Human smart robots. They look like a human. They can do some tasks on their own, like, for example, kitting in the kitting room, inspection. They can deliver components to their designated location. And they might be able to solve some problems. Not sure how much, but this is going to get better and better. I think the other technologies that we have today, including CNC, including 3D printing, including mold and die, including all kinds of press machines, assembly processes. These are technologies that are going to get better. They're going to get more automated. They're going to be easier to use. Look, for example, we have a technology which is called human simulation. Mm-hmm. Human simulation today requires about 1 hour to simulate 1 minute of a human task. Okay? This technology is bulletproof. It works in many companies. It safeguards the health of people. Because when you do the simulation, you actually run kind of an analysis behind it, and this analysis will tell you if the posture is okay, if the weight is okay, if the rack is organized, everything is fully aligned with what is necessary so that our workers are kept safe. But it's very expensive, and people do not want to use it. Mm-hmm. And they struggle. But sometimes they must, because the regulations in America and Germany and Switzerland are forcing this. So they need to prove that they have done this analysis. What we can do today with AI is we can take a picture of the person and maybe a few pictures, run it through AI and get the same human factor analysis automatically. So that's a big change that is happening in our area. And I see these as small incremental changes that are going to make a big impact in the future. Another area is vision. Awesome. Vision. We have robots today with cameras on top of them who can do all kinds of things. For example, they can look at the production line and they can sort things out. Or they can look at quality and they can identify parts which are not necessarily adhering to the right quality standards. What if we could, with use of vision, make sure we don't have any parts which are deformed? You know, these are things, because we'll have a feedback loop. We will be able to collect information and immediately feed back this information, analyze it very fast with AI, feed it back, and fix the problem at the source. Today, we are trying to do these things. We have closed loop manufacturing. We are collecting information upfront from the product. We are collecting information from the production at the shop floor. But can we really say that we have a way to identify the root cause of every problem on the fly and fix it? Not yet. This is something I believe will happen. Vision.
Whenever we talk about production, we're talking about a lot of things, but avoiding disruption in that production is one of those big things, right? Because that costs everybody money. So that's one of the real hopes, as you're pointing out with AI, is that it will both help prevent, to prevent and to predict these kinds of things before they ever happen. So those kind of disruptions are avoided. Is that how you see it as well?
Yes, I want to make two comments. One, we already have technology today that, given that we have a digital twin, a real digital twin of a production system, we can analyze and we can maintain a much better quality and service level of the production system. Today, we can do it. The only limitation we have here is coming from the people on the factory floor. Are they willing to change? Change management is a big thing in this area. I'm hearing many people are saying to me, look, why should we build a digital twin of our factory? We have a similar factory in Germany. Let's copy paste it into America. It's going to be perfect. And I say, no, there is always a chance to improve productivity. And if we have a digital twin and we maintain the digital twin, this digital twin will help us take decisions on the shop floor, but it will also help us predict in advance potential problems on some stations. And let me tell you, it's not important to look at all the stations on the production line. It's necessary to look at the bottleneck stations, because the bottleneck stations determine the throughput of the factory. Okay? If we can avoid challenges, problems on the bottleneck stations, if we can avoid stoppage of bottleneck station, we will be enhancing the productivity and the throughput of the factory. If we can do this and on the same time take care of work in process inventory, take care of labor cost, take care of logistics, enable better quality, we can reduce operation expense. Enhancing throughput and reducing operation expense means that we are helping the company increase the net profit. So my equation is throughput minus operation expense equals net profit. Throughput determines, the bottleneck resources determine the throughput of the factory. Operation expense are all the expenses that are needed to run this factory. If we can do both, increase throughput and reduce operation expenses to a certain level, I mean, no operational expenses is not possible. We can fire all the employees and bring in robots, but they're still going to cost money. So let's be realistic. We do want to have people on the shop floor. We do want to have people that do stuff in a good way. We need to train them, etc. But if we can reduce operation expenses and eliminate waste, we have a winning formula. Throughput minus operation expenses equals net profit. Increase throughput, reduce operation expenses, you increase net profit.
So where's the gap? You know, we talk about these kind of dream environments, or there's aspirations for these environments that can give us as much throughput as possible, preventing manufacturing facilities from achieving that level of performance.
So the first one is change management, being open to implement the new technologies. Not everybody today, even if they build a new factory, is willing to build a digital, to start with a digital twin of his factory before he starts to build or pour the first, ton of concrete. We have quite a bit of examples of this thing all over. People are saying, hey, it's too expensive. I say, what's expensive? To spend 3 weeks now with a couple of consultants and build your digital twin of the factory? Let's see if what you're designing makes sense. Let's see if the distribution of the departments, the flow, the logistics to the production to the storage of the goods, the outside goods is flowing in the right way and so on. And people say, yeah, but we don't have time for this. So that's the first problem. How do you get the people to understand that there is huge value in having a digital twin of their factory and being able to take a digital twin of their product or the products they want to produce and test that their factory can produce these products before they pour 1 ton of concrete? Mm-hmm. This, if we can solve this problem, that's going to be awesome. One of the ways to solve it is to develop an AI copilot that can take a look at the products that you want to produce and automatically design your factory. Create a digital twin of a factory automatically. We're not there yet, but it's something that we're dreaming about.
I love it.
The next thing is, okay, once you have made a decision to go with this concept of digital twin, how do you maintain the digital twin for the long run? This requires some effort because the best ideas on the shop floor come from the employees on the shop floor, and they will implement changes. If we do not record these changes properly, the digital twin of the production system will become obsolete in a few weeks. And then if you do want to make a major change on your production system, you don't have anything to bank on.
We're dealing with technical issues today, but we're back together again. We might look a little different, but Zvi, my last question that I really had for you is, we talk about the need to minimize disruption and maximize throughput, these kinds of things. But we also know that manufacturing is not just dependent on what goes on inside the 4 walls. We have this giant ecosystem of suppliers, other contract manufacturers, and logistics, all of this. How do we extend AI and digital twins to encompass a much bigger, the entire picture out there? And what's missing today in that discussion?
Good question. It's something that we're dealing with. We have a solution called Siemens Digital Logistics, where we are doing exactly this. I'm not sure that we cover the whole range of topics which you mentioned, but what we can do today is partially what you ask for. So we can connect the suppliers and we can make sure that all the information that is needed is reaching the suppliers, and the suppliers can upload their trucks, their parts into the trucks, and the trucks can be managed on the way to the main factory for replenishment of inventory, etc. We are doing it. we're also managing the inventory inside the factory. How can we do it better? By generating a better network of connections, by mapping this network. And actually, if you like, it sounds a bit cornish, but it's a digital twin of the replenishment environment, or digital twin of the supplier network. Now, the challenges here are enormous, because you are dealing with smaller companies. You're dealing with sometimes design houses, sometimes, machine builders, sometimes part manufacturers, sometimes people who are, maybe bigger than your organization, like TSMC, who needs to supply you chips for your controllers. So how do you reach these people? How do you get them on your network? And how do you convince them to open up and share their information at a certain level without any fear that you're going to make you're misusing this information? So it's more or less a humanoid problem, a change management problem, more than a technology problem. I'm not saying that we have all the technology, don't get me wrong, but I think that if you want to have this thing being, developed, you need to have a way to reach these different suppliers. Then the supplier needs to play in this game, and then you need the trucking companies. We have today a project with Daimler-Benz in Germany where we are supplying all their materials with DHL, and there is so much going on there with the drivers and with managing the fleets and with making sure that they're driving in the right direction and they're maintaining, green behavior on the roads, minimizing CO2 emissions, and so on and so forth. So this is not to say not an issue for AI, it's an issue for AI, but it's mostly, and for things, how do you get to these people? How do you make them part of your network? How do you connect them? And then you can operate and use AI. You can collect data, you can analyze the data, and you can make it better, improve it. But this is not going to it's not going to stop there. I think we see it more and more. We are out of the times where in Ford, everything was produced in the same place. Today, everything comes from somewhere. Look, we have a big project in a country where they have never done automotive before, and they don't have a supply chain. And I look at the Chinese, they've built this superb supply chain. They're doing things which are amazing from a supply chain point of view. You sit in a Chinese car and then suddenly you feel it's like a Mercedes-Benz. The upholstery, the knitting, the stitching, everything is perfect. How does it happen? It takes 30 years to build it. Maybe with AI we can do it in 20, 15, but it's not going to be over without, people putting their effort into it. In this country where they want to build an electrical car and they don't have a supply chain, they have to rely on supply chain coming from all over the place, which means they have to make sure that their order is the right order, comes on time, on a ship or on an aircraft. This is going to be extremely expensive and time consuming. And if you don't build your supply chain within your place, within your country, it's going to be very difficult for you to be a number one in your industry.
Zvi, I want to thank you so much for bringing your expertise, your experience to us today and sharing with us. Thank you so much for joining today.
Take care.